All right, today we're going to do something that feels almost impossible in our modern world. We're going to talk about the science of human nutrition, but we're going way back to the basics, what our bodies actually need to thrive.
I mean, think about it. Keto, vegan, paleo, every single day, right? There's a new diet, a new superfood, another study telling you exactly what you should eat, and then another one telling you the complete opposite. It's just a constant flood of conflicting advice, and let's be honest, it is so confusing.
Okay, so for this explainer, let's just hit the big reset button. Forget the trends, forget the headlines, just for a few minutes. We're going to try to cut through all that noise and get right back to the fundamentals, the actual science of what our bodies are asking for.
So, where do we even start with all this? Well, let's begin with the big picture. What is nutrition science really? When you strip it all down, it's simply the study of how the food we put in our mouths becomes the fuel and the building blocks for, well, everything our bodies do.
Right. If you were to crack open a textbook, this is pretty much the definition you'd see. Human nutrition is all about getting essential nutrients from food to, support life and good health. It sounds simple enough, but those two little words right there, essential nutrients, that's where everything gets really interesting.
So what does essential even mean in this context? It's actually really simple. It's any substance our body absolutely has to have to work properly, but, and this is the key, it can't make on its own. Or at least not in the amounts we need. So that means we are 100% dependent on our food, on our diet, to get these things.
You can basically sort all of these essential nutrients into two big families. First up, you've got the macronutrients, the macros. These are the big guys, the ones we need in pretty large quantities. And then you have the micronutrients, the micros. Just as critical, but as the name suggests, we need them in much, much smaller amounts.
Okay, let's dive into that first family. It's time to meet the macronutrient team. These are the real heavy hitters. A great way to think about them is like this. They are both the gasoline that fuels your car and the steel and glass used to build it in the first place.
And this team is made up of three members you are definitely familiar with: carbohydrates, proteins, and fats. These three are the foundation, the bulk of what we eat every day.
And that fuel and bricks analogy is just perfect for remembering what they do. Carbs and fats, they're mainly the fuel, giving us the raw energy to get through the day. And then proteins, along with some fats, they're the bricks, the actual structural stuff we use to build and repair everything from our muscles to our cell membranes.
And here's where you can really see that fuel part in action. Look at this. Carbohydrates and protein, they both give us about 4 kilocalories of energy per gram. And yeah, that's what we all just call calories. But then, check out fat, 9. A whopping 9 calories per gram. That's more than double. It's a perfect illustration of why fats are just such a dense, concentrated source of energy.
So let's look at each one. First, we've got carbohydrates. You can think of these as the body's go-to, quick-access energy source. It's what our system loves to burn first. And they come in all sorts of forms, right? From simple sugars you'd find in an apple, all the way to the complex starches in foods like grains and potatoes. Then we have protein. These are the master builders of the body. They're made from these little building blocks called amino acids, and they literally form the structure of our muscles, our skin, our hair, but they also build something called enzymes, which are like millions of tiny, microscopic workers inside you, making sure all the body's chemical reactions happen correctly.
And last but not least, in the macro team, we have fats. And, they get a bad rap sometimes, but they do so much more than just store energy. Fats are absolutely crucial for building the protective outer layer, the membrane, of every single cell in your body. And just like there are essential amino acids in protein, there are essential fatty acids, like the famous omega-3s and omega-6s, that our body can't make. We have to eat them.
Okay, so we've got our fuel and our bricks. We have energy and structure. But what actually makes the whole system work? What makes it all run smoothly? Well, that's where the mighty micronutrients come into play. If the macros are the fuel and steel, the micros are the spark plugs and the tiny precision tools that make the engine turn over.
And this family has two main branches that you've definitely heard of: vitamins and minerals. We talk about them all the time, but what they actually do can sometimes feel a little vague.
And here's the most important thing to understand about them. Unlike the macros, micronutrients give you zero energy. They are not fuel. Think about it. A spark plug doesn't provide gasoline. Instead, they're the tools and spark plugs that allow thousands of chemical reactions to happen in the body. Without them, the whole engine just stalls.
Here's a fantastic historical example of just how powerful these tiny things are. For hundreds of years, sailors on long voyages suffered from a horrible, deadly disease called scurvy. Then, back in 1747, a ship's doctor named James Lind ran an experiment and figured out that giving sailors lime juice, a citrus fruit, prevented it. But what's really wild is that it took almost another 200 years before scientists finally identified the specific micronutrient doing the work: vitamin C.
The other part of the micronutrient team is minerals. These are actual elements from the periodic table, and they have super specific jobs. You know, calcium is the stuff that makes our bones hard and strong. And iron? It's a critical piece of hemoglobin, which is the molecule in our red blood cells that's responsible for carrying oxygen from our lungs to literally everywhere else in our body.
So there you have it. We've got our fuel, our building bricks, and our special tools. The whole system seems pretty well designed. But what happens when the balance gets thrown off? When we have too much of something or not nearly enough of another? This is maybe the most important part of the whole story.
We all know the word malnutrition, right? But I want you to look really closely at this definition. It's a condition where you get not enough or too much of a nutrient, and that's a huge deal. Malnutrition isn't just about not having enough food, it is fundamentally a disease of imbalance.
In fact, major health organizations actually break it down into 3 broad types. First, there's undernutrition, stunting, wasting. That's what most of us picture. Then there's micronutrient malnutrition, so getting too little or too much of those vitamins and minerals. And then there's the third one, which can really catch people off guard: overweight and obesity. It's officially classified as a form of malnutrition.
And this really shows the wild paradox of the world we live in now. At the exact same time that you have almost 900 million people who are undernourished, you have more than 1.4 billion adults who are overweight or obese. We are somehow dealing with 2 massive, opposite problems at the same time. It's a global challenge of imbalance on an unbelievable scale. This chart just drives the point home perfectly. Let's just take one example: iron. If you don't get enough, you can get anemia, which leaves you feeling exhausted and weak. But if you get too much iron, it's literally toxic. It can cause severe damage to your organs. It is such a clear, powerful reminder that in nutrition, more is definitely not always better. Balance is everything.
Which kind of leaves us with one last big question to think about. The science gives us the blueprint, right? We understand the macros and micros, the fuel, the bricks, the spark plugs. We get it. But in this crazy modern world with a million food choices and a million challenges, are we actually being good architects with that blueprint?